All right, so this should be the first movie that you watch in terms of understanding scientific measurement and dealing with the reduction of laboratory data. So you need to be able to read scales. That's the very first thing. You have to be able to read scales, understand accuracy, understand precision, especially precision, and read the scale properly. There is only one way to read a scale. This is the key. You read a scale, and this isn't written down, you read a scale, all scales, to one estimated place value. To one estimated place value. You have no choice. There is no other way to read a scale. All measurements with all instruments are made to one estimated place value. If the instrument's estimated place value is hundredths place, then that's what you read it to. You have no choice. You don't say, well, I'll just read it to the nearest tenth. No, you read it to one estimated place value always. Now, that estimated place value is the precision. We also call the precision the uncertainty, but that's it. All measurements are made to one estimated place value. The estimated place value is the precision or uncertainty. So that's the main idea and understanding of all instruments. One estimated place value. Now, let's look at rules for reading scales. The actual rules, like how do you actually read them? Understanding, of course, that you read any scale to one estimated place value. All right, so here are the rules for reading a scale. Here's a scale on the left. You want to identify the large place value. Okay, so the large scales are going to be 0, 10, next will be 20, and then 30, etc. So that'll be tens place. That'll be tens place. So that's the place value that it represents, tens place. Now identify the small place value, and that's going to be count the number of smallest graduations. Okay, it'll equal 10. So you're simply going to count them. Tens is the large place value, and then count the number of smallest gradations. It will be 10. But you go 0, then 1, etc., and you'll get 10. Let's speed this up a little bit. You get the idea. So 5, 6, 7, 8, 9, 10. Okay, so pretty straightforward. 10 graduations. And then you want to divide the larger place value by 10 by the number of graduations. And the place value for the small graduation will be equal to ones. It's ones place. So tens divided by 10 is ones place. That's the next place value. So now, now we know that it's ones place. That's the small place value. And now you want to check out the space between. Okay, we're going to take that and we're going to expand it, and then we're going to clean it up a little bit. Get the graduations a little bit under control. Okay. Then you want to mentally divide the distance between the two small graduations into 10 estimated graduations. So there they are. There's 10 estimated graduations. And so you're going to now number them mentally, and you're going to have them numbered from 0 to 10, where the middle would be 5. So that's just an easy reference point. So you don't have those graduations written in, but you know they're there. And so ones divided by 10 is going to be tens place. So the estimated place value will be tenths place. All right, this is called the estimated place value. It's called the uncertainty, or it's called the precision. So the estimated place value is the precision. Okay, now we're going to do some practice. We're going to look at this. Let's look at this one very closely. All right, we're going to do this one. All right, where it's halfway between the sixth, looks like halfway between the sixth and seventh graduation. Okay. All right. So we know that. Let's look at this closely. Now, many of you can figure this out pretty carefully, and you'll know that it's going to be 16.5. However, the method that I use here should be learned, because when you have a measurement that's a little bit more confusing, you just simply use these very basic techniques to find any measurement. It's foolproof. All right, so that's where the sixth comes from. Okay, the sixth is from the sixth graduation. That's ones place. Okay, and then, so it's going to be between 6 and 7. So then it's halfway, remember, so that's going to be 5. So it's going to be 16.5. Okay, so the value is 16.5. And the precision is going to be tenths, or 0.1. That's how you write the precision. You write the precision 0.1. If it's tenths place, you simply write 1 in the tenths place. Now we want to find the precision and measurements of each scale. Okay, notice how the number of significant figures increases as the precision increases. What is happening to the accuracy as well? All right, so here I have a scale from 0 to 10,000. So what's going to be the precision? Well, the precision is going to be 1,000, because you know that the small gradation is 10,000s place, and then you see that space there uh, between the 0 and 10,000. That's going to be mentally broken up into 10 places. So 10,000 divided by 10 would be thousands place. So the precision is thousands place. So what does that mean? Well, thousands place, what that means is this, is that the smallest place value that's going to contain a significant figure will be thousands place. So the smallest place value that will contain a significant figure for this instrument, is what the precision means, will be thousands place. So watch. And what I'm going to do is I'm going to make the precision better for each successive slide, each successive instrument. I'm going to make the precision better and better. And watch what happens, the same measurement, what happens to the precision and the accuracy. So 5,000. So 5 is in the thousands place. And that's the smallest, what did I say before? That's the smallest place value that will have a significant figure. So now I'm going to have a slightly better instrument. Now it's going to be hundreds, is going to be the precision. So 5,500, that's the measurement. All right, you see how the precision is better, and now I'm going to increase it, and I'm going to have a precision of tens, and then it'll be 5,550, and the accuracy will be 3. See how the accuracy is getting better. The higher the number, the better the accuracy. That's the number of significant figures as well. So the accuracy is actually the number of significant figures. So you can see how things are getting better as I get better precision, I get better accuracy. Now this is for the same measurement, so you can do that. You can compare the scales if you're measuring the same material. Now you have 5 significant figures. Now I have hundredths place. So things are getting better. Okay, so let's just continue and see what happens. Now this is going to be thousandths place. Now 10,000ths place will be next. All right, so I'm just going to flip on there a scale, and that's 10,000ths place. And that's the value. So now I have 8 significant figures. Okay, now what I want to do is I want to try the following. Find the precision of each scale. Okay, so I have A through L. Right? I have A through L. I have 12 scales. So let's look at A. We'll do A first. See how the large graduations is thousands. Okay, thousands divided by 10 will be hundreds. All right, good. Then the estimated place value, divide that by 10. Okay, so hundreds divided by 10, that'll be tens. So the estimated place value, remember what I said, you must read, no choice, you must read every instrument to one estimated place value. So the estimated place value will be not thousands, it'll be one less than the smallest gradation, so that's going to be thousands is the larger, and then hundreds, right? And then tens will be the estimated. So the precision of A is tens. B, so think of it this way, 2 less than the largest graduation. So B would be hundreds, then the smallest gradation would be tens, and then it would be ones. So it would be plus or minus ones. So there's the scale. A, the estimated place value is tens. And then B would be ones, and there it is. So I'll let this run, see if you can figure them out. Okay. So that's it. So you should be fairly good at this point. Now let's do some more practice. Now it says try the following, find the measurement. So we're going to take the scales we just did. We had 12 scales, A through L. And we're going to place 2 measurements on each scale. And you're going to have to find what the measurements are. Now, remember, you must record each measurement to the estimated place value. Must be. So here's the first one. So scale A is going to be 1 and 2. All right. So I'm going to have to figure out what those are. So I have my answer sheet, and I'm going to cut out each scale just to make it easy to read. So the first measurement is going to be 1,000, and then 100, 200, 300, 400, 500, and then 600. So it'll be 1,600 because it's right on the line. You need to estimate the last place value. So it must be the tens place. So it's going to be 1, 6, and then the 0 in the tens place will be significant. How do you indicate that that 0 is significant? It's not on the end. You can't put a period there. You need to use a bar. So 1600 is the answer, and you need the bar there. All right? Because why? Because that tens place is estimated. All right, it's estimated. So you're estimating that it's exactly on the line, not above it, not below it, but exactly on the line. Remember, you must make the reading to one estimated place value. The estimated place value is tens place. So I have to estimate that where that arrow is. I am declaring that I am estimating the arrow to be exactly on the line. So that 0 means that it's exactly on the line. So now you should be able to do all of these. You see that the first two measurements are the tens place. And then G, see I'm changing as I go down. I go in and out of different instruments. Just got to keep track of things. And so you should be able to do these. I'll skip to the end, and I'll meet up with you near the end of the video. So I decided to check in with you, see how you're doing, and I'm going to change up a little bit, and I'm going to just read more scales. Try the following. How's it going? Try these. All right. So here are 3 scales and 3 measurements, and I have the answers right there, so you can have easy reference. So things should go very quickly now. And then we'll have even more scales. Scale, 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 scale. All right. And then H. I'm estimating that it's the 7 is the estimation. Could be 6, could be 5. Remember, it's plus or minus anyway. All right, here's scales A through C. So we're going to start with A. So that'll be 50.0, right on the line. That 0.0 means that it's right exactly on that line. All right, so I think you have enough information to finish this up. All right. Good job. So the next one you want to read is, or listen to, is Reading Scales Movie 2. Okay. Hope things went well, and just keep at it. You can read. You can look at these movies more than once. Just practice, practice, practice. Remember, this is a skill, so you got to practice.